Properties of characteristic equation. Okay, the first property. The characteristic equation is unity at omega is equal to 0 and is given by, okay, so what is that? Phi x of omega at omega is equal to 0. What is the value? Phi x of 0, that is equal to 1. Okay, so the characteristic function is 1 at omega is equal to 0. That is phi x of omega at omega is equal to 0. That is phi x of 0 will be 1. Okay, the proof of this is phi x of omega is given as the expectation of, here expectation is missing, so it is expectation of e power j omega x, e power j omega x. Okay. Now we substitute omega is equal to 0. If you substitute omega is equal to 0, we get phi x of 0. Phi x of 0 is equal to expectation of e power 0. So it is equal to e power 1, that is equal to 1. Okay. So we know that expectation of a constant will be 1, so that is expectation of constant will be constant only, that is expectation of 1 will be 1. Okay, now the maximum amplitude of characteristic function is unity at omega is equal to 0. The second property, what is the maximum value of characteristic equation? It is unity. Where it will occur? It will occur at omega is equal to 0. So that is phi x of omega is less than or equal to phi x of 0. Okay, so we just now we have discussed that the phi x of 0 it is having the value 1. Okay, now if you find out phi x of omega, the value of characteristic function at any other locations will be less than or equal to the value at omega is equal to 0. So so that is the our second property. Okay, so proof of this is phi x of omega is equal to what? Expectation of e power j omega x. Yes or no? It is expectation of e power j omega x. Okay, now the amplitude of phi x of omega is what? Mod phi x of omega is equal to mod e power j omega x. Okay, e power j omega x. Now, what is the expectation of e power j omega x? The formula is integral minus infinity to plus infinity. Okay, fx of x e power j omega x dx. Okay, so from this magnitude relation, we know that mod xy value will be always less than or equal to mod x into mod y. Okay, now what we do, we apply this modulus to the terms inside this integral. So if you apply like that, what happens? The value whatever we are getting will be less than or equal to by applying the modulus to the terms inside. Okay, so mod phi x of omega will be less than or equal to integral minus infinity to plus infinity mod e power j omega x mod fx of x dx. Okay, so we know that what is modulus of e power j omega x value will be always 1. Okay, because we know that modulus of e power j omega x can be written as cos omega x, okay, plus j sine omega x. Like this we'll write e power j omega x. Now if you find out what is the modulus of this, what is the modulus of this? Okay, what is the modulus of this? Okay, so this can be written as square root of cos square omega x plus sine square omega x. Okay, so what is cos square omega x plus sine square omega x is value 1, no? So that is why mod e power j omega x value will be always 1. Okay, so now what is that we will be having? We have integral minus infinity to plus infinity mod fx of x dx. Okay, so we know that what is its value, ma? So it gives us what is the area under probability density function. This value will be always 1. Okay, so that is why what is mod phi x of omega? Mod phi x of omega value will be less than or equal to 1. Okay, and we see the third property. The third property is that phi x of omega is a continuous function of omega in the range minus infinity less than omega less than infinity. Okay, so from this, what is that? Phi x of omega is continuous function. Okay, so we know that what is phi x of omega? It is integral minus infinity to plus infinity e power j omega x fx of x dx. Okay, since omega is continuous function, since omega is continuous function, e power j omega x is also continuous. So that is why phi x of omega is a continuous function. Okay. Now we see the fourth property. This is very important property. Phi x of minus omega and phi x of omega are conjugate functions. Okay. So see that phi x of minus omega, how do we write? Phi x of minus omega can be written as phi x star of omega. What is phi x star of omega? It is nothing but conjugate of phi x of omega. Okay, and phi x star of minus omega will be equal to phi x of omega. Okay, so we know that phi x of omega will be equal to what? It is expectation of e power j omega x. Phi x of omega is equal to what? Expectation of e power j omega x. Okay, and similarly phi x of minus omega, phi x of minus omega is equal to what? Expectation of e power j minus omega x. Okay, so what is that we are doing? We are replacing omega with minus omega. Okay, so now phi x of minus omega is equal to what? It is expectation of e power minus j omega x. Okay, now if you take the conjugate, okay, so what happens? This minus will become plus. Okay, so that is why, say if you apply the conjugate, okay, if to remove this minus sign, what we have to do? We have to apply this conjugate. Okay, so that is why we are applying conjugate here, so that this minus sign will be removed, and these two relations are same. Expectation of e power minus j omega x is equal to expectation of e power j omega x conjugate. Okay, so if you bring this conjugate inside this, what happens here? Cos omega x plus j sine omega x will become cos omega x minus j sine omega x. Yes or no? So because e power j omega x is a complex term, okay, if you apply conjugate, that minus will be changed. You will be getting a minus sign. Okay, so that is why phi x of minus omega will be equal to what? Phi x star of omega. Similarly, phi x of minus omega, phi x of minus omega is equal to what? Expectation of, here omega should be replaced with minus omega. Okay, so now if you apply conjugate, if you apply conjugate, what happens? Okay, you bring this conjugate to the terms inside, this plus j will become minus j. So what is that? Here we get e power minus j omega minus omega x. So what is this we get? We get expectation of e power j omega x. We get expectation of e power j omega x. So what is expectation of e power j omega x is nothing but phi x of omega. Okay, 5x star of minus omega will be equal to what? 5x of omega. Similarly, 5x of 5x of minus omega is equal to 5 star of omega. Okay, similarly 5x star of minus omega will be 5x of omega. Okay, then we see that the fifth property here. If phi x of omega is the characteristic function of a random variable x, then the characteristic function of y is equal to ax plus b is given by phi y of omega is equal to what? E power j omega b phi x of a omega, where a and b are the real constants. Okay, so here what is y? Y is given as ax plus b. Y is given as ax plus b. See here, y is equal to ax plus b. So what is phi y of omega? Wherever you have x here, x should be replaced with y. Okay, so it is expectation of e power j omega. Now x will be replaced with y. What is y here? Ax plus b. Yes or no? Now we apply this, we write this complex exponential separately. So what you get, e power j omega b, e power j omega ax we get, yes or no? Now what is that? E power j omega b is constant here. So we will be writing e power j omega b outside. Okay. Now expectation is applied to only the second term. Okay. Now if you observe the second term, what is that we have here? Now we have in the place of x, we have what is that here? In the place of omega, we have omega a. Okay. So in the place of omega, we have omega a. That is why phi y of omega can be written as e power j omega b phi x of omega a. Phi x of omega a. Okay. So now we see that sixth property. If phi x of omega is the characteristic function of a random variable x, then phi x of c omega, phi x of c omega is equal to phi c x of omega. Here c is there. Uh, there is a c here. Phi c x of omega, where c is the real constant. Okay. So we see this property here, the proof of this property. Okay. So here we know that phi x of omega is equal to what? It is expectation of e power j omega x, yes or no? Now phi x of c omega, phi x of c omega is what? Omega should be replaced with c omega. So we get e power j c omega x. Okay. Now this can be written as expectation of e power j omega cx. Okay. Now in the place of x, what we have, ma? In the place of x, we have cx, no? That is why here in the place of x, we will be having cx. Okay. So phi x of c omega, phi x of c omega will be equal to phi cx of omega. Okay. Now we see that seventh property here. The if x1 and x2 are two independent random variables, then phi x1 plus x2 of omega will be equal to 5 x1 of omega, 5 x2 of omega. Okay. So here, if 5 x of omega is equal to what? Expectation of e power j omega x. Now in the place of x, we will be substituting x1 plus x2. Okay. So 5 x1 plus x2 of omega is equal to what? It is expectation of e power j omega x1 plus x2. Okay. Now we write this exponential separately. So it is expectation of e power j omega x1, e power j